In the name of Allah. Hello to the ICCKE ICCKE 2021 respectful attendees. This is Mohammad Heydari. I'm representing my paper titled Graph Representation Learning Towards Pattern Network Analysis on behalf of Dr. Babak Teimourpou from Department of Industrial and Systems Engineering, Tarbiyat Modarres University. In this research, a graph representation learning approach employed to create, analyze, and find similarities of the patents data registered in the Iranian official gazette. The patents record were scraped and wrangled through Iranian official gazette portal. Afterward, the key entities were extracted from the scraped patents dataset to create the Iranian patents graph from scratch based on novel NLP and NER techniques. Finally, thanks to the utilization of novel graph algorithms and NLP methods, we identify new areas of industry and research from Iranian patents data, which can be used extensively to prevent duplicate patents, familiarity with similar and connected inventions, awareness of legal entities supporting patents, and knowledge of researchers and linked stakeholders in a particular research field. There have been a few studies on Iranian patenting work outside Iran, mostly conducted in the United States of America, yet until very recently there had been no effort to carry a deep exploration into the patents registered in Iran Patent Office. Iranian Official Gazette is an affiliate organization of Iranian judiciary in charge of publishing many kinds of public or legal notices, including acts of the parliament, laws and regulations, company registration and deregistration, wills, trademark registration, and patent registration. Iranian Official Gazette launched an online explorable database available at arca.ir to prepare a free of charge global access to information content of the patents registered in Iran. Graph representation learning. Many significant functions requires projections over nodes and edges in the network analysis. This study attempted to predict the most likely node labels in the network in a typical node classification task. Here, node-to-wake algorithm was used as an algorithmic framework for learning continuous feature representation for the nodes in the patents network. Node-to-wake. Node-to-wake, like word-to-wake, which was introduced in 2013 by Google, was mostly employed by skipgram to manage the network clustering. Skipgram is based on the distributional assumption that words in analogous contexts tend to have analogous concepts. To augment the skipgram model towards the network information, recent works such as Debug and node-to-wake were used as the resemblance between the network and the document, which is an ordered word series. Node-to-wake aims to create embeddings for the nodes in a graph. The embeddings themselves are learned in the same way as word-to-wake's embeddings are by using a skipgram model. The most important role of node-to-wake is to explain how it generates a corpus. Such a generation depends on understanding word-to-wake process by a skipgram model. Our research objectives will be introduced in this part. Mapping the patent activity of a country based on IPC, which stands for International Patent Classification, is the straightest method to calculate the technological specialization and technological scope of the country through distribution of its patents over different technological areas. The purpose of this study is to map the patent registered in Iranian official gazette portal, known as the main patent registry based in Iran, in 2016 until 2019. The study attempts to address the three following questions. Number one, what are the most significant IPCs among the patented invention? Number two, which invention is like the patented invention? Number three, who is the most potential innovator in each specific innovation field? So the study is to distinguish and discover the pattern in the innovation activity in Iran and accordingly shape a new landscape for future visionary and experimental research. The dataset. The patent source is Iranian official gazette known as the main patent registry based in the country. Since the data were in Persian, the data gathering phase faced some text processing challenge. Therefore, a heavy pre-processing was initiated on text collection by a specific regular expression technique to extract the key entities of the problem to construct the patent network. Subsequently, the textual database of the patent was created in JSON format. The patents database contains the following attributes among the patents: international patent classification, patents owner, gender and nationality, inventor, and legal supporting institutions. Web crawling and data cleaning. Crawling. To implement the scraping files, web crawling technique was utilized to gather the desired data and create the patents dataset. A crawler was developed to fetch target data from the patents repository from scratch. It is worth mentioning that all the crawled data, including nodes and the relationship between them, are public data available to all users on the Iranian official gazette portal. Cleaning. After scraping data from the patents registry repository using the crawling techniques, a specific regular expression was developed to identify the desired entities in a suitable Persian language style. Since the patents were recorded in the repository in Persian, as this language possessed some incompatibilities in text processing, a heavy processing seemed vital to obtain the key entities in standard format. Research methodology. Research was carried out in the following brief steps: repository selection, web scraping by novel crawling techniques, data pre-processing, reshaping data into the structured style. Part 2. Creation of patents structural database, which is divided. Extraction of necessary information about legal supporting institution. Extraction of necessary information about innovator, for example, gender and nationality. Extraction of necessary information about patents, for example, IPC, subject, innovator's name and owners. Part 3. Graph creation, application of node2vec to detect similar patents based on mutual IPC. Latent pattern discovery in patent network analysis. Result. Part 1. The outcome of our study is divided into different sections. So it could help draw a technology roadmap, increase product reusability, and save time as the most valuable asset. The table in the left describes number of registered patents in each IPC subject area, and the table in the right describes nodes and IPCs with highest degree centrality in patents network. Result part 2. As you can see, the word cloud of the dataset is visualized by visualization technique. The picture on the top describes the most mutual IPCs code, and the picture below describes the most mutual patents keywords in the dataset. Result part 3. As you can see, our final patents graph visualization is developed by NetworkX package. And in the result part 4, you can see geographical distribution of innovator nationalities. Conclusion. The present research explored a specific kind of innovations field. In real world, patent results can be used to analyze the relative competitiveness of a country at international level. This study was conducted based on IPC to recognize the technological categories that represent the patents mentioned. A representation learning approach was utilized to detect most similar patents in their specific innovation roles based on IPC. The mentioned dominant categories, including more than half of the patent subjects registered in the network with an overall of 63%. As a proof that chemistry is among the dominant classes in the patent, IPPI and IPC rank top in top supporting research institutes in the results section of the study that highlights the significant role of chemistry among the patent subjects. Our contribution is utilization of various graph representation learning algorithms to discover latent patterns in patents data registered in Iranian official gazette. Thanks again to the respectful ICCKE ICCKE 2021 attendees. God bless you all.